Welcome to solverfy.
So in this problem, it says the z-axis is defined as the bond axis. Draw a picture that shows overlap of each of the following pairs of orbitals. Indicate whether a sigma or pi bond forms. So the z-axis is the bonding axis. So for the first one, we have px and px. So if the orbitals are along the bonding axis, they will form sigma bonds. Otherwise, they're going to overlap side by side to form a pi bond. So the x orbital is perpendicular to the z-axis. So we're going to have the side-by-side overlap of the p orbitals to form pi bonding. So then for the next one, we have s and pz. So the s orbital is just going to be a sphere, and then pz is going to be along the bonding axis. So because this is along the bonding axis and we have a p and the s orbital overlapping, this forms a sigma bond. So for the next one, we have sp2 hybrid that is formed from the px, pz, and s orbitals overlapping with s. So in this case, we know that the s and the p orbitals have hybridized to form the sp2 hybrid orbitals. So the px, pz, and s have hybridized. So we're going to draw the px and pz. And then we can show that it's hybridized with the s orbital. So sp2 hybridization is observed in trigonoplanar molecules. So basically, we would draw this shape to show the sp2 hybridized orbitals. Also keep in mind that this is along the x and the z axis. So we would also want to show that it is running along these axes like this. And then we would have overlap with the s orbital. So in this case, we're just going to show the overlap of the hybrid with the s orbitals of the neighboring atom. In this case, we have one of the p orbitals along the z-axis. So in this case, we will have sigma bond formation because when we have sp2 hybridization, it results in sigma bond formation. And then we will have the py orbital left over available to form a pi bond. So if we have another py orbital, we will be able to form a pi bond with the remaining py orbital. But if we are only taking into account the sp2 hybridized orbitals, then we will form sigma bonds.